Can and keep track on this time because it's now 10:20. In 10 minutes, I need to be done with this one and then spend the next 20 minutes on the final one. So if I can, 10 minutes for this one, okay? All right, looking up here at this. This is propose an environmental solution, okay? So when you're given a proposed environmental solution, you'll probably start off with just regular questions about APES information. So looking up here on my screen, following along with me, we'll say this. Here's the aquatic food web in the Chesapeake Bay region. A says this, based on the information in the diagram, identify a primary producer. So just give it a couple seconds and I'll ask you to shout out what you think it is. That way everyone has a chance to think about it. Which one of these is a primary producer? And what do you think? Phytoplankton would work?
Yeah.
And aquatic plants. So should I put both of those?
One. No, only one.
Just one, right? There's no need. It asks for a primary producer, right? Next, based on the information in the diagram, identify an organism that is an omnivore. Wait. Give people a chance to think. You should be thinking. This is a simple one. We learned it in 7th grade, probably even in 5th grade. And what is it?
Ducks.
Ducks?
Yeah.
Big clams and mussels and aquatic plants.
Yeah, very good. An omnivore, right? The word omni or prefix omni means what? Like when you say an author is omniscient or the reader is omniscient, right? It means that they can see everything. Yes? Omni means all. So in this case, it means eating both meat and plants. Any other omnivores here?
Probably the dog.
You can't say probably. It doesn't matter. It doesn't matter if you look into this thing and you're like, okay, it maybe could. I get that, right? But it doesn't matter what you think. It just matters what it shows on here. According to this, no other omnivores that I can see. Okay?
The small fish, it said when I looked at the.
Oh, you can do small fish actually. I think small fish would work.
Zooplanting means
They're
there are more animals.
The animal ones, yeah, I think that would count. I think small fish would count too. So these two would count. Very good. All right, next up. Based on the information in the diagram, explain why an increase in the bald eagle population, again, wait on your answer for this, why an increase in bald eagle population could lead to a decrease in osprey population in the short term. So just think for a second how that could be in effect. So what I like to do is when they say increase, I draw little arrows next to it. You'll have a test booklet, and you can draw these on there too. So like increase bald eagle, why might there be a decrease in osprey numbers? I'll start your hand up first. What you got?
If the bald eagles go up, they're going to eat a lot more large fish, meaning the ospreys will not have to.
Yeah, it'll have less food, right? But there's a key vocab term here you should mention. Competition. Ecological niches, yes, good. But you can also say competition, right? Because they're in direct competition with each other for that one food source. So if one goes up, the other one will obviously go down. One of the things I ask my kids to do, and we'll talk about this later, in 7th grade, is I say, show me. So when I say show me mutualism, do y'all know what to do when I say that? We did it in here. Mutualism is plus.
Yeah.
Show me commensalism, +0. Parasitism, +-. And when I say show me competition, they show minus. Because competition negatively affects both. It don't benefit nobody. Okay? Well said. All right. Now, D, based on the information in the diagram, identify a primary consumer that is also a generalist species. So take a second. This one requires some outside knowledge beyond just this. So looking at that, identify a primary consumer that is also a generalist. Take a second. And go. Small fish?
Sure, yeah.
Ducks?
Yeah.
Zooplankton.
Zooplankton? What does generalist mean?
It eats pretty much anything.
Pretty much anything, right? And I mean, if you're looking at this, I think the smartest answer to pick would probably be small fish, because what do you see?
Also a general.
Everything.
It's getting some things here, right? And it's also a primary consumer, yes? Primary means it eats first, yes? But it's eating a lot of other things. So you can qualify it both ways. I think ducks would probably qualify as well, right? Because they're getting multiple things here as well. Okay, so they're able to eat other things. All right, it doesn't always mean omnivore, but it seems to be similar to omnivore at this point. Okay, here's my advice here for designing an environmental solution. When it moves on from the content to the solution, when picking an environmental solution, pick the one that you know the most about. And I know that seems like it should be the obvious one, but it's totally not. And I know because I've graded yours, right? You all pick really weird, like eco-justice ones, which I'm important and support, right? But just because it might be the most impactful thing you could do, does not mean it's the one you know the most about. Does that make sense? If they say, what could we do here at the school to like make a difference? You could say, oh, we could run a solar power generator, right? You could be careful of the amount of heat that we're putting into the water in the bathrooms. You know what I mean? Like, but you could also just say, pick up trash. You know what I mean? Like, it doesn't have to be complicated. It just has to be correct. Does that make sense?
Yeah.
Okay. So over here, looking at E, this is what I want you to think about here for a second. The city of Baltimore is located on the Chesapeake Bay. Describe one environmental problem in the Chesapeake Bay that is directly related to the numerous roads and parking lots in Baltimore. So think for a second about an environmental problem in this Chesapeake Bay region. You've never been there, but you should be able to figure out from the next statement, which says that's directly related to the numerous roads and parking lots in Baltimore. So think about problems you know associated with roads and parking lots. Some people are looking out the window. If that helps trigger your memory, makes sense to me. But think about a simple problem with roads and parking lots. And what you got? You just mumbled something in your mask.
Runoff from cars.
Runoff from cars. What in the runoff? What runoff are you talking about? Huh?
Well,
Oil. Okay, so you do toxins there. Good. That's one good one, right? What else? Yes.
Thermal pollution.
Thermal pollution is a big one, right? Because they heat up a lot in the summer, and then the rain hits it and carries that into the lakes, rivers, and streams, right? Let me ask you this. The oil one. Simple one, I get that, but do you know what its actual effects are? How that oil affects the other things in the area.
It increases the turbidity of the water and is toxic to most, like, animals that live in the water.
Yeah, as long as you know what the effects are, I think it's a good choice to pick. But just because it's an easy one you can think of doesn't mean it's the one you can answer the most about. Does that make sense? The one with thermal pollution, do you know what the effects could be if you thermally pollute the water in the area?
The warmer the water gets, the more gas it releases low.
Ooh, brilliant. Yeah, the hotter it is, the less gas it can hold. So therefore, it's less oxygen in the water, right? That's really good. As long as you can figure out a solution and you know the cause and effect of it, that's a good one to go with. Does that make sense? You can also do infiltration, right? The amount of water that's able to make it through into the ground. That can affect the plant species that live in the city and stuff like that, right? There's a number of things you can do here. You can talk about the deforestation caused by the building of all these roads, right? And the erosion that would happen because of it. So it says here, make a claim that proposes a realistic solution to the problem you identified. So assuming that you're doing this with me and not just sitting here, you hopefully thought of a solution that you would use for this. So assuming that you understand what the problem is, right? Whatever problem you picked, do you have a solution for it? What's your solution for yours, for the oil thing?
I was thinking maybe like make a filter for it.
Filter where?
What's it called? I can't remember the word right now. I'm sorry, I can't remember the word.
No, that's okay. But it's an important question, but here's the deal. Guess when you have to know that word? On the test with this. So if you find you're in that situation where, oh, hold on, I don't think I can go any further with this. What should you do? Back up, pick another solution.
Yeah.
Okay? So make sure you know all the things through. Yes?
Well, I mean, for the oil thing, since most runoff goes into the sewers first, maybe like divert all those and, go into a filter, and the filter would work because, well, oil does rise above water. Just do the same thing that the sewage plants do.
Exactly, yeah. Run it through a water treatment facility. Yes? It doesn't say just filter, right? It's not somebody out there with like a sieve. You know what I mean? Like specifically say, okay, run it to a treatment center, right? That can pull those toxins out of the water before re-releasing it into the Chesapeake Bay, right? Great solution. Okay? What about your one for the thermal pollution?
Just like have, I don't know.
That's a tough
Have
one.
Channel it through somewhere, so it's a really crappy answer, but channel it through somewhere where it has enough time before it reaches the bay to cool down.
Similar thing, another water treatment center, right? Somewhere where it can be like stored for a minute before it's released to release some of its heat. Yeah? Okay, all those things matter for sure. Okay? And I would also say for that, you can also make the pavement more porous. So in other words, less runoff, right? If water is able to get through the cement, right, it'll go into the ground where it will cool down. So the more porous the cement that we use, right, the less runoff issue you have in general. That would work for both solutions. Okay, if we have actually like a bunch of holes in our concrete, it could cause less issues for the bay. Yeah.
Another one for his is we could add more green spaces so that water can run into the.
Very good. Yeah, more green spaces or green roofs, little things to help prevent more runoff, right, and cool things down. Okay.
Out of time. I don't know.
Amount of time. Oh, okay. All right. For the solution you proposed, describe one additional benefit that could result from the implementation of your solution. So, sending it to a water treatment facility would help not just for the oil, but also for the thermal pollution side, right? Find an additional benefit to your solution. And then lastly here, this is a big one. Describe one unintended consequence of concentrated poultry feeding operations on the biodiversity of the Chesapeake Bay region. So if I can, this just takes you in a whole other level, right? And now it's asking about concentrated poultry factories. What happens at these CAFOs?
They be getting like antibiotics.
They be getting antibiotics, right? Yeah, good. What else?
Their waste, storing
Their waste, storing their waste. Because we know, whether it's the antibiotics they have, right, that they could poop out, or the poop itself, right? When it rains, what can happen to all that stuff? It can run off where?
The bay.
Into the bay, exactly. And it would cause what?
Yeah.
Eutrophication. So simple. Okay, that's obviously what they're looking for here, right? You got poop, you got biodiversity, and in the Chesapeake Bay. So if you have all this eutrophication, it's going to kill off all those animals because of it.
Microscopic level, it's doing wonders.
Yeah, yeah. And the antibiotics would not be great either, because then you're going to build antibiotic resistance in those things, in the bacteria and stuff in the Chesapeake Bay, which would be less good as well. Whew. Okay. All right, that's good for that. Now things are going to get way trickier. So I want you to really pay attention to a couple things. Number one, a lot of this, like I said, is going to be on you. Between now and that test, right, you are the one who needs to learn this information. So like I mentioned before, my first AP class, what did I score on the AP test?
3.
A 3. Now the ones I took after that, I got 2 4s and a 5. Why did I do better with my other ones afterwards? I took an L. Oh, that was the way? Is that the way? This way? I took a hard L on that AP US History one, and I barely got the credit that I needed, right? And I took an L because I was overconfident and I went in underprepared. So I knew that since I was taking 3 APs my senior year, I needed to make sure I sit down, find time to study, and prepare myself. It's the same thing here for you. So when you take a college course, who is responsible for you learning the information? You are, okay? Not me. That's how it works here in I guess high school and stuff, because we're the ones responsible for the test scores. But in college, you have to learn it, right? If a professor taught something once in the class, guess what they would expect you to do? But know it. They taught it to you. Your job was to do what?
Yeah.
Well, yeah, remember, but learn it to begin with. You are a senior. You've been in school for what, 12, 13 years? Almost all of you by now? So if I can, you should be experts at learning. You should know how you learn. I don't learn by listening to Mr. Ellis talk. So I go home and I watch videos online, right? I don't learn by taking notes. So I draw all my stuff. You know how you learn, so you better be applying that now, okay? Right? Don't just show, I actually don't want to know that. Look, you're not in school to do work. A lot of people just show up here thinking, I'm here to do my work until I pass the course, and then I move on, okay? You're in school for one reason. You're in school to do what?
Learn.
To learn. Now, you may be taking courses that you don't necessarily want to learn about, which is fair enough. But you still have to learn the material there so that you can do what? Pass those tests and get that college credit. You see what I'm saying? Okay, so you're here to learn one way or the other, whether it's to pass the class or, this is the big one, for your future occupation. If you are a science person and you are currently in a science class, you should be applying yourself a whole bunch because this is going to come up. Do you see what I'm saying? If you're not a science person, learn enough of it to get the 3 you need. You know what I mean? To move on with your life. Does that make sense?
Yes.
So make sure you're applying yourself to learn what you need to learn. You are going to have a long and painful college experience if you're just there to take some classes. If you just show up there and be like, yeah, I'm here for biology 9600. Okay, well, cell bio is going to kick your behind. Okay? You're going to have a long and painful experience if that's what you're there for. Okay? If you expect there to be a teacher, you will be sadly disappointed. In college, you don't have teachers. What do you have? Professors. That's a difference. What does that difference essentially mean?
They don't care about you.
They care. There are some nice ones there. But they're not there to teach. They are there to, what does profess mean? I profess my love for someone.
Give you information.
Giving you information, okay? And you learn it. That's how it works at that level. So again, one more time. Between now and the test, you hadn't picked it up until now, you got about a month. We're almost at, what is it? What day is it? Day 9? So we're just over a month before your test to learn the stuff that you have not learned so far. That's why I ask people to come outside with me and talk about which tests you were successful on and which ones you were less successful on. So you know which ones you need to spend more time learning. Okay, if you want to follow along with me now, go to the homepage, go to Wednesday, click on Design a Solution, or Propose a Solution with Calculations, because that's what we're on right now. If you want to read along with me because you can't read this off the board, do that on your computer. Otherwise, follow along with me here. When we do propose solutions, you will have one that's just straight solutions and one that's half calculations, half solutions. So take a look right here. Can you have calculators?
Yeah.
Yes.
Are you sure?
Yes.
Yeah.
It says students.
Yes.
All right, what kind of calculator?
That's not
Four functions.
Yeah, anything you want, essentially. Are you going to need to be able to graph?
No.
No. Are you going to need quadratic stuff? No. You're just going to need a simple basic calculator, okay? For some simple basic math. Yes? I'm cool with you using those, but I don't know if they're going to have you bring it or if they'll supply it. I'm not sure how we're doing it here yet. Okay? Next up, pre-algebraic word problems. And they're talking here about stuff, but many students do not know how to apply math to real-life problems. That's essentially what this is. Okay? So your ability to juggle word problems will matter here. This FRQ was half math. And number 4 here, this is the big one. Students must do what? Show work on the FRQs. No work?
Okay.
No credit. How many experienced this in my grading practices earlier this year? Did anybody experience this? No math work, no credit? Okay.
But then I fixed it.
Then you fixed it. That's right. Then you had to fix it. So that's the point. Even if you're correct, right? Because if you just show a correct answer, they don't know if you just copied off of someone or not. You have to show that you know the material and you know the process. Units in setup and answer. Make sure you label your units. Those who had me in physical science, I would tell you it was wrong, no matter how correct the number was, if you did not include what?
Yeah.
Your unit. And that will happen here as well. Okay? Make sure you label your numbers with units. There is no formula sheet. That means what?
You gotta memorize it.
To memorize some formulas. They will give you the formula in some cases, okay? But there are certain ones you have to memorize. I'm going to talk about which ones those are here. Okay? Let's see. Other teachers have reported that the math FRQ scores are typically the student's weakest score and often drops kids from a 3 to a 2. You can take this entire test and not answer a single math question and pass. That is definitely true. But if you already know you're on the fence, right, and then you don't answer any of the math problems, then guess what's going to happen?
You failed.
Yeah, you're not going to get that credit, okay? So make sure you know where you're sitting on this, okay, and what you're committing your time to. Anyways, let's talk about this. Math skills kids should have already learned, but probably forgot before this class. Number 1, dimensional analysis. What's dimensional analysis?
Like, what do you,
I don't want to
like
I can see it in my brain.
spatial calculations?
Conversions of units
Yeah.
from one form
See what now?
to another, one dimension to another, right? Kilometers per hour to meters per second. You're changing the dimensions, okay? Let me see, continuing here. Density, all right? This is taught in chemistry. Dimensional analysis is taught in chemistry, and it's also taught in Algebra 1. But in chemistry, density is really, really easy, and it's taught in middle school too, and maybe even in elementary school, all right? But density is simple. It works like this. Density equals mass divided by volume.
I remember.
Very good.
I know for you, so yeah.
And it makes a pretty cute little this. Look,
It makes it hard.
m over a v, which makes a heart. So that's one way you can remember what density is. Okay? Now, if I can here, that's the density one. pH, just know the basics. What are acids?
There's a 0 to like 7.
0 to
6.
6. You could say 6.9 if you wanted to.
7 is the water.
7 is neutral. And what are the basic ones?
8 to 14.
Yeah, 7.1 to 14. Okay?
I can't believe you said that.
All right, continuing here. Let me see. I'll just go back over pH in a second. Anyways, half-life, which we taught in chemistry and physics, physical science, we did that as well. Scientific notation. I'm assuming you guys did that in math class and mastered it a long time ago, right?
Yeah.
Okay. Percentages. Many students don't remember how to add, subtract, multiply, and divide using percentages. If you can't tip, right, that's a problem, okay? You should fix that, okay? But regardless, percentages are how you tip, right? What should you tip?
20%.
If you tip 10%, you are disrespecting the person who you are tipping. You want to tip anywhere from 15 to 20%. 20% is is recommended, but if you're a server, you probably tip more like 25% because you know what the life is
Yeah,
like.
exactly, yeah.
I do it based on their service, not percentage.
Fair enough, but keep this in mind. People, when they initially made tips as a thing, it was because in the South after slavery, they didn't want to pay these workers like a fair wage. So what they said was, okay, we'll pay you like this small amount, and you can make the rest with tips. And so that's what recently freed slaves had to live off of, was tip wages. So like, I get the service can affect the tip, but at the same time, like, that's the only way the person's going to be able to pay the rent is off of those tips. Yeah.
Yeah, ever since I watched the Adam Room Everything episode and worked at Chick-fil-A, I always get $20.
Yeah. Yeah, across the board. Me too. Same thing every time. All right, anyways, let's talk about formulas that you need to memorize. You need to maybe write this thing down somewhere, or you might need to highlight this. This should all be up online for you if you need it, regardless. But formulas you need to memorize. Population math. We're going to go over this when we talk about Unit 3, but it's pretty straightforward. Population growth rates, right? The crude growth rate is just simple. What's this? Births minus
Yeah,
over
But I don't believe.
total population, right? If you have more births than deaths, then the growth rate will go up, right? More deaths than births, the growth rate will go down. It'll be negative. Over here is the same thing, the growth rate, except now it's including what? Migration. What is immigration?
They're coming in,
They coming in. What's immigration?
they going out.
They going out. Okay. Moving along, percent change. This is one that you're going to want to know, okay? And if I can, there's a simple way to actually memorize this. I don't know that I have time to go over it in too much detail, but check it out. Percent change works like this. Ending amount minus starting amount over the starting amount. There's a simpler way to memorize this, which is this. No. And I say it like this because it works pretty simple. Take the new amount, right, which is your ending amount, the new amount,
Old amount.
minus the old amount divided by
Old amount.
the old amount. That's one way you can memorize that. A little mnemonic device for you, okay? New minus old over old.
No
No.
minus,
Okay. Let me see. Metric conversions. You got to know your metric conversions. King Henry
Died by drinking chocolate milk.
died by drinking chocolate milk, okay? And there's two additional ones you might want to add into that. And if you don't have these somewhere, I would totally write them down. You ever heard of a gigabyte?
Yes.
Yeah.
Okay, a gigabyte, 1 gigabyte is 1 times 10 to the 9th power bytes.
Okay.
What number is that?
And
Anything times 10 with a 9 exponent is times 10 with 9 zeros, which is, a billion. This is a billion bytes.
a billion.
Anything that's a giga is a billion. Anything that's a mega, like a megabyte, which you've heard before too, is what? 1 times 10 to the 6th power. So that would be a
No.
6 zeros, guys. That would be
100,000.
100,000? Has 6 zeros?
Billion.
Thank you. Just say it confidently. A million, okay? So a billion, a million, and then kilo is 1 times 10 to the 3rd, which is 1,000. Okay? Kilo is 1,000. All right, so those are the only other ones that I would suggest you know. The rest of them are just straight from there. You can see there's like milli here, there's micro and nano, but I don't think you'll need to know those. They usually don't go into it. But either way, it's just the reverse of these. Micro is a millionth, nano is a billionth. Okay? All right, let me see. Moving on. Density we talked about, makes a heart. pH scale we talked about already, but don't forget this little detail. It's a logarithmic base 10.
Oh, yeah.
That means every one number you go up, the strength is multiplied by
10.
10. So if I increase the pH from, let's say, an 8 to a 10, right? How much more basic is this 10?
Because I'm trying to, 100, yeah.
It's 100 times more strong, right? Because up 1 to 9, right, is times 10, and then you multiply by 10 again, and what's 10 times 10? 100. Are we cool with that idea?
Yeah.
Okay, each jump is multiplying by 10. All right, and then lastly, primary productivity. We'll talk about this too when we go over Unit 1, I think. Net primary productivity, pretty simple. The total amount of production minus
The rest of the work.
expression, what you're using, will give you the net. The net is the total amount after you take away the bad things. Yeah? Okay, half-life we've done in here. I actually think you guys did pretty good on the practice problem in here, right? But for half-life, for those who need to know or remember, particles are radioactive and unstable, and over time they will do what? Decay. And the amount of time it takes for half of the amount to go away and decay is called the
Half-life.
half-life. It's a time, okay? And so if we're looking up here, I always suggest keeping track of the following. Know your starting amount, right? Oh, Lord. Okay. Anyways, know your starting amount, know your ending amount. Let's say, oh my goodness gracious. Right? And then all you do is you go and reduce by how much each time? By half. Okay, each time it's reduced by half, and each arrow is going to represent a half-life, right? So I have 1, 2, 3 half-lives. It took 3 to get down there to that number. Are we cool with this idea?
Yep.
I have all this stuff, by the way, I think saved up there. There are some YouTube videos of me going over all how to do this, right? Okay, and then here's an actual problem. I don't know that we have time for it. So what I'll do is I'll stop here and do this for me, please. For those who want practice, okay, if you go to our Canvas page and you scroll down here to, not that, design environmental solution and propose solution doing calculations. See this one right here? If you do this, oh goodness gracious. Anyways, there's an actual problem on there I want you to do. So again, I'm not going to give you a grade for it if you do it. It's just for me to give you feedback if you want to practice it. But do it over the weekend, all right, before Tuesday, and I'll offer you some feedback on it whenever you do it.
So is this supposed to be like a submission button? 'Cause
Is there not one?
no.
I will make one.
Which one is it?
Okay? It's the design environmental solution proposing or doing calculations. Okay? In fact, if you want to do any of those 3, if you want to do the investigation or the problem proposal solution, I'll promise I'll try and give them some feedback over the weekend. Okay? Any of those 3. But really focus on the one doing calculations because I think we all need some practice with that. Okay? Any other questions? Cool. All right, then you're free to go. Virtual folks, you're free to go. If you have any questions, you can stay behind, okay? And I see some questions on there now.